when we left off yesterday, we had determined that 1 mole of an atom, a mole is like a counting unit, like a dozen of something. So 1 mole of an atom is the amount of that substance that contains Avogadro's number worth of particles. So 1 mole of helium has 6.022 times 10 to the 23rd atoms of helium. 1 mole of water contains 6.022 times 10 to the 23rd molecules of water. So it always contains that number of particles of that substance. So just like a dozen contains 12 in it, whether you're talking about donuts or squirrels, it's 12 of them, right? It's the same principle here. If we're talking about atoms of hydrogen, it's that number of atoms of hydrogen. If we're talking about molecules of water, it's that number of molecules of water. Okay? Then we looked at Avogadro's number, and then we looked at molar mass. Okay? When they determined how many particles should be in a mole, and this is from the previous slide, they decided that the number of particles that should be in 1 mole should be the same as there are number of particles of carbon in exactly 12 grams of carbon, which sounds like a weird number to pick, but there's a very specific reason that they picked it. And that is that if you look at what we defined as a unified atomic mass unit, okay, I want you to remember that they said that 1 unified atomic mass unit is equal to 1/12 the mass of a carbon-12 atom. Okay? So, if 1 carbon-12 atom is 12 unified atomic mass units, right? Because 1/12 is 1, so if a carbon-12 atom, 1/12 of that is 1, then 1 whole atom is 12 of those. And 1 mole of carbon-12 is equal to 12 grams, then 1 AMU, or 1 unified atomic mass unit, is the same as the mass in grams. So, all of this to say that if you remember, we said these mass numbers here on the board, right, on the periodic table, were in unified atomic mass units, right? So, the unified atomic mass units and the molar mass of an atom are the same because of the way they set this up. So when I ask you for the molar mass of a substance, you can look at the periodic table and find it. So the molar mass of carbon is 12.01 grams. The average atomic mass of an atom of carbon is, in unified atomic mass units, is 12.01 U. It's the same. Okay? The only difference for this is that there are some atoms, like oxygen, for which in nature we do not ever find one singular atom of oxygen by itself not bonded to anything. It's what we call a diatomic molecule. So if you are finding an oxygen, it is bound to another oxygen or it is in a compound. So if I ask you for the atomic mass in U of oxygen, it's 15.99 U. If I ask you for the molar mass of oxygen, because oxygen always has another oxygen with it, its molar mass is double what's on there. So it would just be the atomic mass times 2, because you would have 2 of them. Always. Okay? So, and I will be sure to point that out to you if we use it in the calculation. I'll say, hey, this one is diatomic, so its molar mass is going to be different. Okay? Questions?
So does diatomic just mean that it is bonded to?
Diatomic just means that it's always bonded to another one of itself.
Okay.
Mm-hmm. Yep. My screen is being weird. So, now that we know what moles are, what Avogadro's number is, and what molar mass is, and where to find it, now we can use these as conversion factors. Okay? So you can convert between the mass of a substance in grams, amount of it in moles, and number of particles of it, using these three pieces of information that we just learned. So if I were to give you the mass of a substance in grams and ask you how many moles it was, you could use the molar mass to convert. If I gave you a number of moles and asked you how many grams, you can use the molar mass to convert back. It's just like when we were converting between units of measurement. Okay? Just instead of saying there's 1,000 meters in a kilometer, we're saying there's a specific number of grams of this substance in 1 mole of that substance. Okay? So, it all seems very abstract when we look at it like this. It makes more sense in practice, so we're going to practice it. First, I'm going to show you some sample problems, then you are going to do some sample problems. You'll try them first on your own, and then we'll do them on the board together so that you can see them done correctly. And then when we're all done, so it'll be, I'll show you some, we'll do some together, and then you'll do your post quiz, which will be you trying them on your own. Okay? All right. So, if we have a molar mass for helium, which we can get from the periodic table of 4.00 grams, that means there's 4.00 grams in exactly 1 mole of helium. And I want to know what would be the mass in grams of a 2 mole sample of helium. Then I can convert like this. I'll take my 2 moles of helium and I will multiply it by the molar mass of helium. So 4 grams of helium per 1 mole, and I will get this answer. Notice that I set it up so that moles are on the bottom so that they will cancel out, and I will be left at the end with grams of helium. So just like when we're converting between units of measurement, this is the same. All right. The same process can be done if I give you a number of atoms and I want to know moles as well. So in this case, we have to use Avogadro's number. We know that we have 3.01 times 10 to the 23rd silver atoms. And once again, it messed up my formatting on my exponents, but those are supposed to be exponents. 10 to the 23rd. And we know that in every mole of silver, there are Avogadro's number of silver atoms, 6.022 times 10 to the 23rd silver atoms in 1 mole of silver. And so then we can cancel out atoms of silver and be left with moles of silver. And if you recall, we said that the number of particles in a mole is equal to how many particles there are in 12 grams of carbon-12. So they experimentally counted that number, and now that's what we say 1 mole is. Okay, now you're going to get a chance to try some of these on your own. So what I'm going to do is I'm going to go to a blank screen, and I'm going to put a problem up. You guys are going to try it on your own, then we'll do it on the board together, and then we'll do another problem, okay? So to start off, we are going to convert from grams or no, let's start with moles. We'll convert from moles to grams. So let's say you have 3.50 moles of copper, which is written with the symbol Cu, and I want to know what is my grams of copper. Go ahead and try to do that conversion on your own, and then we will convert together. Remembering that you can get molar mass off the periodic table. So, to start this problem, we would say, I know I have 3.50 moles of copper, and I know from the periodic table that the molar mass of copper is 63.55 grams for every 1 mole. Notice that I put moles on the bottom specifically so that they would cancel out with the moles that I have, and I would be left with roughly 222 grams of copper. All right, so let's clear this off and let's try one the other way. Chemist made 11.9 grams of aluminum, written Al. How many moles, I don't know why it did that, moles of aluminum were produced? Okay, try that one. Okay, so if we start with 11.9 grams of aluminum, then we need the molar mass. So we want moles on the top this time because we want grams to cancel. So we know for every 1 mole of aluminum, how many grams do we have according to the periodic table? 26.98 grams of aluminum. So now our grams of aluminum cancel. Didn't mean to cross through the 9 there. And you should wind up with 0.441 moles of aluminum. Okay, so he did not make a whole mole. He made part of a mole of aluminum. Okay, let's try one of these, but for number of particles. Okay, how many atoms of silver, which is written Ag, are in 3.01 times 10 to the 23rd Oh, it shouldn't say how many atoms. That's my bad. It should say how many moles. I read it wrong. Are in 3.01 times 10 to the 23rd atoms of silver. So this time we want to go from number of atoms to number of moles, so you are going to need Avogadro's number for this. Okay, so we start with 3.01 times 10 to the 23rd atoms of silver, and we use Avogadro's number, so 6.022 times 10 to the 23rd atoms of silver, and we know that that's 1 mole of silver. So when we do that, we come out with 0.441 0.500 moles of silver, which should be familiar because this is the example one we ran in our notes.
Okay, so when you've got the equation out, what do you actually do? Like, what is what are you doing? Because I had it all out, I just didn't know how to solve it.
So what you're doing is this top part right here would be being multiplied times this and divided by this.
Okay.
So remembering, when we multiply exponents, you multiply the base numbers and the exponents add. When you subtract, or when you divide exponents, you subtract. Okay? So this last example problem, I am just going to work on the board for you because it's a little more complicated and we're running out of class time. Okay? But I want you to watch because this one is a multi-step problem. If you want to see the words and follow along with me, we're working the problem on page 88 of your textbook. Okay? Where it says, how many moles of silver we just did that one. I want to know what is the mass in grams of 3.01 times 10 to the 21st atoms of cobalt, which is written CO. So notice here we are going from atoms to mass in grams, and that is not a single step problem. There is no direct conversion for us between number of atoms and mass in grams. We have to go via the center point of moles. So we need to convert from atoms to moles and then from moles to grams. So what that process looks like is we start with the 3.01 times 10 to the 21st atoms of cobalt, and then we're going to multiply that. We know that 1 mole of cobalt is always going to have 6.022 times 10 to the 23rd atoms of cobalt. Okay, so if we do this math, what we're going to do is we're still going to divide 3.01 by 6.022, but this time the exponents don't totally cancel out, right? This time we are left with 21 minus 23, which is -2. So you're going to wind up with something along the lines of 0.499 something times 10 to the -2, which you could also just write as 0.00499, right? And then that's moles of cobalt. Now we need to go to grams. So we're going to take it by its molar mass. So we know that 1 mole of cobalt has a molar mass of 58.93 grams of cobalt. And you should come out with roughly 295 times 10 to the -2 grams of cobalt.
Which in decimal
Would be 2.95.
2.95?
Believe so. Okay. So, sometimes you're going to get multi-step problems like this where they start you on one end and expect you to go all the way to the other, because we could also give you a mass in grams and ask you for the number of particles in that mass, and you'd have to convert from mass to moles and from moles to particles. Okay? Question. If there are no questions, then you should head on to your post assessment and try the problems there on your own. That would be your homework for today.